Hello everyone and welcome to another video. Today we're going to be talking about equations once again, but we're going to take this one step further. Now, so far, in terms of the equations we've touched, we've solved these all sorts of equations. We've solved some with brackets, with fractions, with pronumerals on both sides, and with all of these types of equations we solved, we always got one solution, right? We got some number that satisfied the equation, that when we substituted it in, it gave us the left-hand side equaling the right-hand side. Now, today we're going to talk about a different family of equations, and these are what we call quadratic equations. And these come in a different form, and the amount of solutions we get sometimes vary. Now, let's look at the form of these equations. Now, these are all in the form of some pronumeral squared equals some number. We call this a constant, or any integer, any type of number. So here we still have our pronumeral, and we have our constant, our number. And when we solve these, we have to approach this in a slightly different way. So I'm going to give you one example. So I want to find a value for x that satisfies this equation, x squared equals 9. So what I have here, let's just take a moment again to consider what x to the power of 2 or x squared means. This means that remember we talked about powers as being a shorthand for multiplication. So this is like saying x multiplied by x gives me 9. And we can think of which two numbers multiply to give me 9. And more importantly, which two of the same number? That's a very key point here. This value for x, we talked about pronumerals. When we use the same pronumeral, that represents the same number. So this value, this number, is the same. So can you guys think of a same number that multiplies by itself to give me 9? Well, I can think of one, and that is that x equals 3. So this goes into there. If I substitute that in, 3 times 3 gives me 9. But also, what happens when I take minus 3? Because minus 3 times minus 3, that's a double negative. And when we multiply two negative numbers, we also get a positive number. So x equals minus 3 is also a solution here. This is how these types of equations vary from the ones we are currently looking at, because sometimes it is possible to have more than one solution. If we look here, we have more than one solution. Now, this is kind of interesting. Now, these solutions vary depending on the constant we have, this particular thing here. Now, we'll talk about that in a second, but let's just look at a way we could have also solved this equation. And let's look at that through another example. So let's do question 2. I want to solve x squared equals 81. Now I have that a number squared gives me 81, but if I have a number squared, remember there's a way I can undo this squaring. And that is to take the square root of this particular thing here. Because squaring a number gives me something else. Taking the square root of a number, of a perfect square, which we talked about before, just gives us the number that was multiplied by itself to give us that in the first place. And what we want to do here, this is another way we can think about these questions, is if we undo this squaring, we can take the square root of this thing. So I'll actually write that down here because that's an important point. So to undo squaring, because remember these equations, when we solve them, it's all about undoing the things that happen around my pronumeral. So to undo squaring, we can take the square root of the number. So what's important here is I'm going to take the square root of this, but with equations, because of this balancing act, this scale analogy I used before, what we do to one side, we have to do to the other side. So I'm going to take the square root of both sides. I'm going to take the square root of this one and the square root of this one. Now, when I take the square root of x squared, I get x. And 81 is a perfect square. So that means that when I take the square root, I'll get a nice whole number. I'll get a nice whole number integer as an answer. So taking the square root of 81, that gives me 9. But also, it gives me minus 9 as well. I have two solutions here. Because 9 times 9 gives me 81, but also minus 9 times minus 9 gives me 81 as well. Now, let's look at another example to see how these different values of C can affect the amount of solutions we get. Let's take another solution, another question. We want to find, we want to find a solution to x squared equals 0. Now, once again, this is like we're finding, for example, x times x equals 0. We want to find what number multiplies by itself to give me 0. Or we can do this square root thing as well. Now, what's the only number that can multiply by itself to give us 0? Well, that number would just be 0. There's no other number that can multiply by itself to give me something that's 0 other than 0. So here, x equals 0. Now here, you may be tempted to think like, okay, well, in the previous examples, I had, when I took the square root of 9, I got positive 3 and negative 3. But 0 is a very special number. It is neither positive nor negative. It's just itself. It's just 0. It represents nothing. So you can't have positive nothing or negative nothing. You just have nothing, right? So 0 is the only solution here. And let me just make a note of that. Here we got one solution compared to, for example, here, we got two solutions. So that's something interesting. So we noticed a lot of the time for when the number on the right-hand side of my equation, this C, when it was something greater than 0, we got two solutions. When it was 0, we got one solution. Let's look at what happens if we do, for example, x squared equals -4. Well, once again, when we look at these types of equations, this is like saying a number times itself gives me -4. Now, just a quick thought, right? I know that 4 is a perfect square, that +4 is a perfect square, because 2 multiplies by 2 to give me 4. But if I have two numbers multiplying by themselves that are the same, there are no two combinations of x that will give me -4. Because take, for example, if we let's say we had, okay, let's let x equals 2. So this is just to test. Now, if I had x equals 2, 2 times 2 gives me 4. So that's not a solution because I need -4. All right, what's the only other combination we can think of? Let's let x equal -2. So we're going to let x equal -2, and we're going to test this again. Well, -2 times -2, I have a double negative happening here. So I'm still going to get +4. And in fact, the only way we can get -4 is if we have two numbers of opposite signs. Because remember, opposite signs multiplying together, so one being positive, one being negative, gives me a negative answer. And because they have different signs, they're not the same number. They're never going to be the same number because opposite signs mean different numbers. So here, we can say that x squared equals -4, I should say, has, in fact, no solutions. It has absolutely no solutions. If you try to put this into a calculator, so you put x squared equals -4, and say you wanted to, okay, square root both of these, and you got x equals the square root of -4, because my square root kills my squaring here, and I want to take the square root of both sides. This thing here, my -4, if I put that into my calculator, square root of -4, you're just going to see math error in your calculator. It's not going to register. It's not going to work. So that means that we can't do this. Hence, we have no solutions for this particular thing. Now, going back to this idea of c at the top, my constant, let's make a note of some of the observations we've made here. So when c is, well, greater than 0, a number more than 0, that's what this symbol just means, more than 0, that number, that quadratic equation provided us with two solutions. When my c, my constant, was 0, that gave me one solution. Because we can't have plus or minus 0. 0 isn't a positive nor a negative number. It just represents nothing. It just represents 0. And when we had it being less than 0, we got no solutions. So these are some really important observations we can make when solving quadratic equations. Now, I'm just going to try to solve one more here. I'm going to do a slightly harder one. Let's call this, I think we're up to question 5. I want to solve this. -2x squared equals -50. Now, don't be overwhelmed here. This is we can solve this equation in a regular way that we've done before, just by solving it systematically. Well, I want to find what number multiplies by -2 to give me 50. And I can find that by taking the opposite operation. We're multiplying here. So I'm going to divide both sides by -2. And what am I left with on the x squared? Well, this dividing by -2 kills this and just leaves me with 1 in front of x squared. Or I can just write that as x squared. And -50 divided by -2 gives me 25. And now that we have it in this form that we've been used to seeing, we're solving this equation, we're stripping away to get it to this form. X squared equals something. And the sign of this number can give us a hint as to how many solutions we'd expect. So this 25 is greater than 0, so we would expect to get 2 solutions. And we find that out by, well, I have an x squared equals 25. Well, x squared is a perfect square. 25 is also a perfect square. So let me try to undo the x squared to get to x by taking a square root of this side and a square root of this side. And when I take the square root of x squared, and once again, what we do to one side, since I took the square root of the left-hand side, I want to do it to the right-hand side. We want to balance the scales here. I get left with x, and what two same numbers multiply to give me 25? Well, that would be 5. 5 is one of them. It would also be -5. That's our second solution, because 5 times 5 gives me 25, but also -5 times -5 gives me 25, because the double negatives multiplying give me a positive. Now, this is just an introduction to quadratic equations. This is as far as we go with it. But it's important to know that this will come up a lot in the later years too. So we're trying to introduce you to this idea of quadratic equations very early, because they will reappear quite a lot in the coming years. But thank you so much for watching, and I'll see you guys in the next video.